Hello students, welcome to Anne's classes. Let's do area of a trapezium and a polygon, exercise 22C. Question 6. The diagonals of a rhombus are 18 centimeters and 24 centimeters. So we have drawn a rhombus here just for our understanding. So a rhombus is a parallelogram in which all four sides are equal. So here the diagonals of the rhombus are given to us 18 centimeters and 24 centimeters. We can take any one. Now we can make this as 18 and this as 24 centimeters. Now we have to find its area. So this is simple. We just have to apply the formula. Diagonals of the rhombus are given and the area is half into product of its diagonals. So that means 1 by 2 into product of its diagonals means you multiply. So 18 centimeters into 24 centimeters. Now we just have to simplify this, cancel, 2 9s are 18 and then we multiply 9 into 24 and that is 216. 216 and we have found the area. So the area will be 216 centimeter square. So this is our final answer. Now this is the first part of this question. We have to find a few other things also. The first thing is we had to find its area and we have found the area. Now let's go to the next part. Here we have to find the length of its sides. So let's begin. Now here we have to remember the sides are AB, BC, CD and DA. We have to find the length of any one of these sides because all four sides have the same measurement. Now how are we going to do that? Now let's first take the first part, diagonal AC 18 centimeters. Let's consider AC to be 18 centimeters. So if this is 18 centimeters, then AO and OC will be 9 each, isn't it? This whole thing is 18. So half this side will be 9 and the other half that side will be 9. So in that case we can say OA is equal to OC and both are equal to 9 centimeters. So we can write that. So this is 9 and this is also 9 centimeters. Similarly, if we take the other diagonal BD and if we take it to be 24, then each half, that is OB and OD, will be equal to half of 24, which is 12. So this is going to be 12 and this is also going to be 12. So we can write that. That means OB is equal to OD and both are equal to 12 centimeters. Now why have we done this? Why have we broken it up? Now here we're asked to find the length of its sides, isn't it? So we have to find one of these sides. To find these sides, we can consider these two diagonals here to form triangles. Okay. Now these two diagonals will bisect at 90 degrees. That means at this point you have a 90-degree angle. So let's write that. Diagonals of a rhombus intersect at 90 degrees. And now we can find, now if I'm going to take this triangle to make it easier, you can take any one of these. Now I'm taking this easier for us to understand it well. Now if we take this triangle BOC, at O there is a 90 degrees. That means this is a right angle triangle. In a right angle triangle, according to the Pythagoras theorem, the side that is opposite to the right angle, that is this side BC, is called the hypotenuse. We can apply the Pythagoras theorem and find the hypotenuse, which is also the side of this rhombus. So apply the Pythagoras theorem in triangle BOC. So in that case, BC square, according to the Pythagoras theorem, the hypotenuse square is equal to the sum of the squares of the other two sides. What are the other two sides of that triangle? OB. So OB square plus OC square. So when you calculate this, you will find BC square. And when you find the square root, you will get BC. You will be able to get the measurement of this side. That's why we are applying the Pythagoras theorem. So now we just have to substitute and do it. So BC square we don't know. We're going to find out. So BC square is equal to OB square. Now how much is OB? OB is 12. Okay, OB here, we have written here clearly, OB is 12 centimeters. So OB is 12 plus OC. OC is this part and that is 9. Here also we have written OC is equal to 9 centimeters. So this is 9. So that means square of these, OB square plus OC square. Now let's continue. BC square is equal to 12 into 12 is 144. 9 into 9 is 81. So BC square is equal to 225. So BC square is equal to so much. How much will BC be? BC will be the square root of 225. And what is the square root of 225? 15. That means BC is equal to 15 centimeters. BC is equal to 15 centimeters. So let's write it there on the figure. So on the figure, BC is 15 centimeters. And what is BC? BC is one of the sides. Remember, if this is 15, all four sides are 15. So we have found the length of its sides, and that is 15 centimeters. So let's write that. So BC, the length of its side is 15 centimeters. We can write it here. This is our answer. Now the third part of the same question is we have to find its perimeter. Now we know the side of the rhombus we just found out, and that we found out to be 15 centimeters. To find the perimeter we have to use the formula 4 into side. So that is 4 into 15 centimeters. 4 into 15 is 60. So 60 centimeters. This is the perimeter of the rhombus. Question 7, the perimeter for rhombus is 40 centimeters. Perimeter is when you add up all four sides, what you get is called the perimeter. So that measurement is given to us, and one of the diagonals is given to us 16 centimeters. So let's consider AC to be 16 centimeters. We have to find the other diagonal, that is BD. Okay, so that is what we are asked to find. So let's begin by saying perimeter of the rhombus. So whatever is given to us, we are writing first. Now, what is the formula for perimeter of a rhombus? 4 into side. Now, why are we doing this? We are doing this so that we get the measurement of the sides of the rhombus. So 4 into side, that means 40 centimeters is equal to 4 into side. And we don't know what the side is. So to find side, we say side is equal to 40 divided by 4. Why is it division by 4? Because we are moving this 4 from here to the other side. It's multiplication. So when it comes there, it becomes division. 40 divided by 4 is easy. 4 tens are 40. So now we have the measurement of the side. The side is 10 centimeters. So let's write it here. So this is 10 centimeters. All four sides. So I've just written it on one side. All four sides will be 10 centimeters. Now, one diagonal is given to us as 16 centimeters, isn't it? So this is 16. That means half of it will be half of 16, which is 8. That is OA is going to be 8. So let's remove this and write OA is equal to 8 centimeters and OC is also equal to 8 centimeters. So let's write that OA is equal to OC and both are equal to 8 centimeters. Now we are going to find out BD. Now how are we going to find out? Remember, when two diagonals of a rhombus intersect, they form a right angle. Okay, so that property is very important because with the help of that we can use the Pythagoras theorem. So diagonals of a rhombus bisect each other at right angles. Let's keep that in mind. Now let's consider only this right triangle BOC. So if you consider this right angle triangle, we have this side 8 and this side 10. We only have to find this side, that is OB. We can use the Pythagoras theorem to help us find this. So let's find that first. So applying the Pythagoras theorem, according to that, what is it? BC square is the hypotenuse. BC square is equal to OB square plus OC square. Now BC square we don't know. We're going to find BC square is already given to us. I'm sorry, 10 square. OB is what we don't know. So we're going to write it as OB square plus OC is given to us 8 square. So here now we can find OB square. That is 10 square minus 8 square. So OB square is 10 square is 10 into 10 is 100 minus 8 square is 8 8s are 64. and that is 36. So OB square is 36. So how much is OB? OB will be equal to the root of 36. What is the square root of 36? 6. 6's are 36, isn't it? So OB is 6 centimeters. So now we have found the measurement of OB. So let's write it there. Let's write 6 centimeters there. So this is 6 centimeters. So we found OB to be 6 centimeters. Now since this has bisected it like this, remember OB will be equal to OD. If that is 6 centimeters, this is also 6 centimeters. So now we can find the length of BD, isn't it? We just have to add up OB plus OD and we will get the length of BD. So let's begin by saying the other diagonal, which is the other diagonal BD. So BD is the other diagonal. So BD is equal to OB plus OD. And how much is OB? OB is 6 centimeters and OD is also 6 centimeters. So together 6 plus 6 is 12 centimeters. So the other diagonal BD is 12 centimeters and we have got our answer. Second part of the same question, now we have to find its area. So we know that one diagonal is 16. We found the other diagonal just now 12 centimeters. To find the area, we apply the formula half into product of diagonals. So area of the rhombus is 1 by 2 into the product of the diagonals, and the diagonals are 16. Product means multiply into 12. Cancel. 2 8s are 16. Now we just have to multiply 12 into 8. 12 into 8 is 96 and we have found the area of the rhombus and that is 96 centimeter square. So this is our answer. Question 8. The length of the diagonals of a rhombus is in the ratio 4:3. And if its area is 384 centimeters square, find its side. So we have to find the side of this rhombus. So let the length of the diagonals. So let's take the diagonals as AC and BD and let it be 4x and 3x based on the ratio. So let AC be 4x and BD be 3x. So if we can find the value of x, then we can find the length of these two diagonals. So let's continue with what else we've been given. We've been given the area also. So area of the rhombus, the formula is half into product of the diagonals. And area given to us is 384 centimeters square. This is given to us. And here half into product of diagonals. Diagonals are 4x. You can take it as 4x centimeters and the other one is 3x centimeters. So here 4x into 3x. Now we can cancel 2 2's are 4. Now let's multiply. So here on this side we have 384. On this side what do we have? 2 into 3 is 6. X into x is x square. Now we're going to find the value of x square first. So x square is equal to 384 divided by 6. And that is 64. So x square is 64. So x will be the square root of 64, which is 8. 8 8s are 64. So we have found the value of x. Now we can find the length of the diagonals AC and BD. So diagonal AB. Diagonal AB is equal to 4AC. Diagonal AC. AC is equal to 4x. And that is 4 into x is 4 into 8, which is 32. So in that case, then look at this now. If AC is 32, AO and OC will be half of that. 32, half of 32 is 16. That means this side will be 16 and this side will be 16. So in that case, then you can write this way. OA is equal to OC, which is equal to 16 centimeters each. So this is when you take only the diagonal AC. When you take the diagonal AC, we have found this. So here we wrote 4x, we substituted x with 8 and found. Now let's take BD. Diagonal BD in the same way, diagonal BD is 3x. That means 3 into 8. 3/8 are 24. Now look at the diagonal BD. The diagonal BD, the whole thing is 24. That means OB and OD will be half of it. That is, half of 24 is 12. So this is 12 and this is also 12. So we can write that. Then OB, carefully write this, OB is equal to OD and that is equal to 12 centimeters. Now, why did we do this? Why did we break up the diagonals into two halves, both 16 and 16 and 12 and 12? Because the question says find the side. To find the side, we can make use of each part here. Because when two diagonals bisect, a 90-degree angle is formed, so we can apply the Pythagoras theorem and find the other side, that is the hypotenuse, and that will be the side of this rhombus. So let's continue. Now here, OB we know is 12 centimeters and OC is 16 centimeters. We found this out, isn't it? So keeping that in mind, remember diagonals of a rhombus bisect each other at right angles. So we're taking only this triangle here, and at O you have 90 degrees. So applying the Pythagoras theorem for this particular triangle, okay, we're using the triangle BOC. According to that, BC square is equal to OB square plus OD square. So BC square is equal to, how much is OB? Here we found out OB is 12 centimeters and OD is 16 centimeters. So this will be 12 square plus 16 square. So BC square is equal to 12 square is 144 and 16 square is 256. Now BC square is equal to, we have to add up these, 400. So BC square is 400. Now we can find the value of just BC by finding the square root of 400. Now here it's very easy to find the square root when you have numbers ending in zeros. Now take only the first number 4. What is the square root of 4? The square root of 4 is 2, isn't it? 2 2s are 4. Then look at the two zeros that you have, pair them up. So here we have paired up, take only 1 from that. So I'm taking 1. So what do I have now? 20. So I have found the value of BC and BC is 20 centimeters. So let's write it there in the figure. We have BC here. Let's write 20 centimeters there. So this is 20 centimeters. So what have we found? We have found the side, and the side BC is 20 centimeters. So we can write that side of the rhombus is 20 centimeters. This is our final answer. Question 9. A thin metal iron sheet is a rhombus in shape. Okay, so let's consider this to be a thin metal iron sheet. This is in the shape of a rhombus. Each side is 10 meters. So each side is 10 meters because all sides of a rhombus are equal. If one of its diagonals is 16 meters, so let's take AC to be 16 meters. We have to find the cost of painting both the sides at the rate of 6 rupees per square meter. So if we have to paint the sheet, we have to find the area of the sheet first, isn't it? So to find the area of the sheet, the formula is half into product of its diagonals. And we've been given only one diagonal. That means the first thing we need to do is find the measurement of the other diagonal. And then we can find the area of this rhombus. So let's begin by writing what we have. Side of the rhombus shaped sheet is 10 meters. Then one diagonal AC, let's take one diagonal AC to be 16 meters. In that case, if this whole thing is 16, half of it, OA, will be half of 16, which is 8, and OC will also be 8. So we can write that. So in that case, OA is equal to OC, which is equal to 8 meters, half of each. Let's write it here. So this part is 8 meters. And here also, this will be 8 meters. So we've written it there. Now, why are we doing this? Now, what we're going to do is we're going to find the measure of this diagonal, isn't it? So if we can get the measurement of this side or this side, we can add up both and get the measurement of this diagonal. So in this case, what we're going to do is we're going to keep this property in mind that diagonals of a rhombus bisect each other at right angles. So here we have this diagonals here bisecting each other at right angles. So let's consider only this triangle DOC. So here it's bisecting at right angles, so that is 90 degrees. Now we can apply the Pythagoras theorem and find the measure of this side. If we get this side, we double it up and get the length of the diagonal. So we're going to apply the Pythagoras theorem. Now here we're going to consider the triangle DOC. In the triangle DOC, the hypotenuse square. Now which is the hypotenuse? If this is 90 degrees, the side that is opposite this, that is DC, is the hypotenuse. The square of the hypotenuse is equal to the sum of the squares of the other two sides. So that means the hypotenuse is DC. DC square is equal to OD square plus OC square. So now let's substitute. DC we already have 10 meters. So let's write that. So this is 10 meters and OD is not given. That is what we're going to find out. OD square. And remember this is 10 meter, 10 squares. And OC is also given to us. OC is 8 meters, so 8 square. So now we're going to find the measure of OD square, and that will be 10 square minus 8 square. OD square is equal to 10 square, which is 100, minus 8 square, which is 64, and this is 36. OD square is 36, so OD is equal to the square root of 36. The square root of 36 is 6 because 6 into 6 is 36. So now we found OD to be 6 meters. Let's write it here. So here this part OD is now 6 meters. That means OB is also 6 meters. So now we can find the length of the diagonal BD. Okay, so let's do that. So diagonal BD is equal to OD plus OB. And how much is OD? 6 meters. And OB is 6 meters. That means the diagonal BD is now 6 plus 6, 12 meters. So can you see we have one diagonal here and we also have one diagonal here. Now since we have both the diagonals, we can find the area. So let's go ahead and find the area of this rhombus. Now that we know the measurement of the diagonals, one is 16 meters and the other is 12 meters, we can find the area of the rhombus half into product of diagonals. So that is 1 by 2 into product is 16 meters into 12 meters. Now let's multiply. So here I can say 2 8s are 16. Now 8 into 12 is 96. So that is 96 meters square. We have found the area. Now why did we want the area? Because this metal sheet is going to be painted. Painting happens inside, isn't it? So that is the area. So now to find that, we have to first think of the rate. What is the rate given to us? It is 6 rupees per meter square. Rupees 6 per meter square. Now to find the cost of painting, one side will be the rate into the area. So rate is 6 and area is 96. So we have to multiply both and see what we get. 6 into 96. And that is 576. That means the cost of painting one side is 576. Now they have told us that both sides have to be painted. So the cost of painting both sides will be 2 into 576. And that is equal to rupees 1152. So this is the cost of painting both sides, rupees 1152. Now this is one answer that we were asked to find. We were also asked to find the distance between the opposite sides of this rhombus. So this is the opposite sides, the distance between the opposite sides of the rhombus. So let's find that. Distance will be area divided by base. So we just have to apply this formula. So area we have found out to be 96 meters square and the base is one of the sides which is 10 meters. So that is 10 meters. 96 divided by 10 is 9.6. So the distance between the opposite sides is 9.6 meters and this is the second part of the answer. Question 10. The area of a trapezium is 279 square centimeters. So we have a trapezium here and the distance between its two parallel sides. Remember, a trapezium has one pair of parallel lines. So here we have CD, this is one, and we have AB. These are the two parallel lines of this trapezium. And the distance between the two, that will be the height. So the distance or the height here is 18 centimeters. So we can write that 18 centimeters. If one of its parallel sides is longer than the other by 5 centimeters. So one we know is longer, the other is shorter. If this is longer than this one by 5 centimeters, we have to find the length of CD and AB. So let's do that. So let's begin by saying the area of the trapezium is 279 square centimeters, which is given to us already. The distance between its parallel sides, the two parallel sides, the distance or the height is 18 centimeters. Now here, let the shorter side, let it be x. Okay, so this is x, that is CD is x. Then the longer side will be, remember, 5 centimeters more than the shorter side. So that will be x plus 5 centimeters. So this is the longer side. Now the area of the trapezium, the formula is half into sum of its parallel sides into the height. So let's do this. So this is the area is already given to us. It is 279 centimeters square and this is half into sum of its parallel sides, and parallel sides are x centimeters plus x plus 5 centimeters into the height, and height is 18 centimeters. So now let's work this out. Let's simplify. So 279 on this side, half into x plus x is 2x, 2x plus 5 is 2x plus 5 centimeters. So 2x plus 5 into 18. Now let's cancel. Here I can cancel 2 and 18. 2 ones and 2 nines are 18. Now 279 on this side, and on this side we have 2x plus 5 into 9. So when we have to multiply that way, remember how to do multiplication. 2x plus 5, we are multiplying this by 9. So first 9 into 2x is 18x plus 9 into 5 is 45. So that is 18x plus 45. So let's write that 18x plus 45. Now we can find the value of 18x. 18x is equal to 279 minus 45. And how much is that? That is 234. So 18x is 234. So x will be equal to 234 divided by 18. 234 divided by 18 is 13. So x we have found out to be 13. And what is x? X is the shorter side. So the shorter side is 13. We can write it here. It's 13 centimeters. And the longer side is x plus 5, 13 plus 5, which is 18 centimeters. So now we have found the measurement of its, the length of its parallel sides. It's 13 centimeters and 18 centimeters. So let's write the answer. The length of the parallel sides is 13 centimeters and 18 centimeters. So this is our answer. Question 11. The area of a rhombus is equal to the area of a triangle. If the base of the triangle is 24 centimeters and its corresponding altitude is 16 centimeters, so we've been given some measurements of the triangle, and one of the diagonals of the rhombus is also given to us, we have to find the other diagonal. Now, if we have to find the other diagonal, since we have one, we need to find the area of this rhombus. So to find the area of the rhombus, first we need to find the area of the triangle because both are the same. They are equal to each other. So let's begin. Area of a rhombus is equal to area of a triangle. Now we've been given base of the triangle and the altitude of the triangle. So now we can find the area, half base into height, which is 1 by 2 into the base, which is 24 centimeters into 16. So here let's cancel. I can cancel 2 and 24. 2 ones are 2, 2 12s are 24. 12 into 16. And that is 192. So the area of the triangle is 192 centimeters square. And this is the same area as the rhombus. So area of the rhombus is 192 centimeters square. So we have the area of the rhombus. We have one diagonal given to us, which is 19.2 centimeters. Now let's consider the other diagonal to be x. Now let's use the formula of area of a rhombus. Area of a rhombus is half into product of the diagonals. So area of the rhombus we found out to be 192, and here this is equal to half into product of the diagonals. So one diagonal is 19.2. Other one we don't know, we're going to call it x. I can cancel 2 and 19.2. 2 ones are 2. Now 19, we can take 18. 2 nines are 18. What is left is 12. So put the point, and 2 sixes are 12. So we have 9.6. So we have 9.6 into x is equal to 192. So to find x, what do we say? We say x is equal to 192 divided by 9.6. So when we do this division, since the divisor is a decimal number, let's make it a whole number by multiplying it by 10. So when we multiply this by 10, multiply this also by 10. So what do we get now? We get 1920 divided by 96. So when you divide this, you will see the answer is 20. So we have found the value of x. And what is x? The other diagonal. We said let the other diagonal be x, and we have found it to be 20. So the other diagonal is 20 centimeters. So this is our final answer. Question 12. Find the area of the trapezium ABCD in which AB is parallel to DC. AB is equal to 18 centimeters, angle B is equal to angle C is equal to 90 degrees, CD is equal to 12 centimeters, and AD is equal to 10 centimeters. Let's follow all these requirements and draw a trapezium. So we have all these here. So we have the trapezium here. It's all very clear. AB is parallel to DC. AB is parallel to DC. AB is 18 centimeters. AB. Angle B is here is equal to angle C, and both are 90 degrees. CD is 12 centimeters and AD is 10 centimeters. So now we are asked to find the area of this trapezium. To find the area of the trapezium, you need to know the measurement of the parallel sides, which we know A, B and CD we already know, but we also need to know the height. So for that we draw this. So draw this DE, which is perpendicular to AB. So draw this in such a way that it is perpendicular. So now this is going to be the height. That means DE is equal to CD. Both will be equal to each other. So AE, now we need to find the measure of AE now. Now how do we find the measure of AE, and why do we need to find this measure? Now if we find the measure of AE, we can use this measurement and this measurement and find the measurement of DE by using the Pythagoras theorem. Now how do we get the measure of AE? AB is 18 centimeters and so much. EB is 12. So if you do 18 minus 12, you will get this. So let's do that. So that is 18 centimeters minus 12 centimeters, and that is equal to 6 centimeters. So now we've got 6 centimeters here. And here can you see this is a 90-degree angle here. So and now we can use the Pythagoras theorem because we have two sides. We can find the third side. What does the Pythagoras theorem state? That the square of the hypotenuse is equal to the sum of the squares of the other two sides, and AD is the hypotenuse because it is opposite the right angle. So let's write that. So DE is equal to BC. Let's remember that. Let's apply the Pythagoras theorem in this triangle. This time which triangle are we looking at? We're looking at triangle DEA. DEA. Or we can look at ADE, one of these triangles. Okay. Angle DEA, according to the Pythagoras theorem, the hypotenuse, what is the hypotenuse there? AD square is equal to AE square plus DE square. DE square. Now let's substitute wherever we have values. So AD we have, that is 10 centimeters. So this is 10 square is equal to AE also we have, that is 6 square. DE we don't have, so we leave it as DE square. So now to find the value of DE square, we say 10 square minus 6 square. So DE square is equal to 10 into 10 is 100 minus 6 square, 6 are 36, and that is equal to 64. So DE square is equal to 64. So how much is DE? DE is the square root of 64. And what is the square root of 64? 8. That means we have found DE. And what is DE? DE is the height. So we have found the height to be 8 centimeters. So let's write it here. So this is 8 centimeters. So the height of this figure of this trapezium is 8 centimeters. So now that we have the parallel sides measurements and the height, we can find the area of this trapezium. So parallel sides are given already to us. AB is 18 centimeters, DC is 12 centimeters. The height is 8 centimeters. Now the area of the trapezium, the formula is half into sum into parallel sides into sum of the parallel sides into height. So area 1 by 2 into, now parallel sides are 18 plus 12 into the height, which is 8. So this is half into 18 plus 12 is 30 into 8. So here we can cancel. So we can cancel 2 and 30, 15, and 15 into 8 is 120. So we have found the area of the trapezium, and that is 120 centimeters square. So this is our final answer. So with this we come to the end of this exercise. Thank you, children.